So in the environment of VLAN, we have two very important topics, and that is the collision domain and the broadcast domain. So a domain means an area under which something can happen. So an area refers to the domain. So we have the collision area under which the collision can happen, and the broadcast area under which the broadcast can happen. So as per the definition, a collision domain is an area under which the collision of packets can take place while they are using a shared channel. That means such an area in which the collision of data packets can take place when the nodes are using a shared medium or shared channel is known as a collision domain. Now we are going to see in detail what this shared channel means and what is this data packet collision in the next slide. But for now, the collision domain is an area under which the data packet collision can take place when the nodes are using a shared medium or shared channel. Similarly, the broadcast domain is an area in which every node that is inside that area will receive the broadcast message. So if one node broadcasts the message, so every node that comes or falls in that area or broadcast domain will receive the broadcast message. So let's talk in detail about these collision domain and broadcast domain. Now before going further, let's explain what is a collision. So let's say I'm trying to send you a data packet, and at the same time simultaneously you're trying to send me a data packet. If the path is common, then there will be a point at which both of our messages will collide. That is known as a collision. Similarly, in the networking world, when two or more nodes try to send a data packet simultaneously, then a collision happens between those data packets. This usually happens with networks that are using the Ethernet hubs, because as we are told, hubs are not intelligent devices. They do not have their own IQ. They flood the network every time they receive a packet. And when two devices in a half duplex hub channel, half duplex means at one time only one node can send the message, and when the message is received, only after that the next message can be transferred. So in a half duplex hub channel, when two devices send simultaneously, a collision of data packets happen, and the area under which or the link under which the collision can happen is termed as the collision domain. So each port of the hub is in the same collision domain. That means every node that is connected to the hub will be in the same collision domain. So every device that is connected to the hub is in the same collision domain. If the collision happens, it will happen within the range of the network that is connected by the hub. Each port of a switch and router is in a separate collision domain. And by port, we mean that each link that is connecting to the other node. So each link of a switch and router is in a separate collision domain. So that means they can lessen the chances of collision happening by segregating the collision domains at each port. So these are 2 points that you need to remember. First one is each port of the hub is in the same collision domain, and second, each port of a switch and router is in a separate collision domain. So now I guess you might have known what is a collision domain, an area under which collision of data packets can happen when the nodes are using a shared channel like a bus topology or an Ethernet hub channel, etc. Now the second concept is the broadcast domain. So broadcast domain is also a part of the network or the area of the network inside which every device that is inside that range will receive the broadcast message if any node does a broadcast. So for example, if I send a broadcast message, every number of nodes that falls in my range will get that broadcast message. So when any node sends a broadcast message, the message goes to every node that falls within the range of that broadcast domain. Now there is one point in broadcast domain that you need to highly remember, and that is the routers separate the broadcast domains at each of their port. So an area under which the nodes can receive the broadcast messages, those areas are separated by the ports of the routers. So now let's see what are the differences between a collision domain and a broadcast domain, and how you can identify which one is a collision domain and which one is a broadcast domain in the next slide. So a collision domain is an area under which the collision of data packets can happen while they are using a shared channel, and by they we means the nodes. So if the nodes are using an old Ethernet hub half duplex channel or a bus topology, a collision can happen inside the area, and that area is termed as a collision domain. While on the other hand, a broadcast domain is an area of the network under which all the nodes will receive the broadcast message if one node sends a broadcast message. So that is the physical difference. Now the logical difference is that every port of a switch and router is a separate collision domain. Like I told you that switches and routers are intelligent devices. They can separate the collision domains by making use of different ports and VLANs. Thus, every port of a switch and router is a separate collision domain. On the other hand, we have every port of a router is a separate broadcast domain. So like I told you, routers are the boundaries of broadcast domains. The broadcast messages do not go across the boundaries of a router. So every port of a router is a separate broadcast domain. So now I guess you might have got the difference between a collision domain and a broadcast domain. Now the physical difference is very simple, because the area in which the collision can happen is a collision domain, and the area under which the broadcast message can be received is a broadcast. The main difference lies in the logical difference, that is, every port of a switch and router is a separate collision. So switch and router, separate collision domain, router, separate broadcast domain. So now let's see how much you got with this activity.